Hi everybody, today's lesson is 3-6 about perpendiculars and distance. And so after this lesson, students will be able to find the distance between a point and a line and two parallel lines. So just a little bit about vocabulary. First of all, the term between two lines measured along a perpendicular line is always the same. Okay, and then between parallel lines, if you make a perpendicular at any point between two parallel lines, it'll be the same distance. And then if you want to find the distance between a point, in this case point C, and this line, you can simply create a perpendicular to it and find that distance from C to this point of intersection. And that's actually what we're going to end up doing in the two examples that we're going to do today. And basically here's just some more information about perpendicular lines and parallel lines. So let's take a look at our examples. I'm just going to warn you right now, this is a little bit long. Lots of things to do, but we have example 1. We have this line L. Here's line L, and it contains the points 1, 2, and 5, 4. And we're going to find the distance between L and point P. So just like what we talked about in the vocabulary, we're actually going to find the distance between this point, and imagine that we created this perpendicular line right here. And in order for us to figure out this distance, we need to find this point right here, which is the point of intersection. So we're going to bring back a lot of what we used from algebra. So step 1, we need to write the equation for this line of L, and we do that by starting with finding slope. And so we know that slope is rise over run, so I'm going to do 4 minus 2 over 5 minus 1, which gives us 2 over 4. And so our slope is 1/2. And so the next thing we want to do is figure out what our y-intercept is. And again, I'm just going to use slope-intercept form. I'm going to pick one of my points. In this case, I'm going to pick the first point and substitute it in, including our slope. And now I'm going to solve for b. Subtract 1/2, subtract 1/2. And so this gives us 1/2, and I'm actually going to change my 1/2 to 3/2 because we're going to use fractions down the line we have to solve systems of equations, and instead of converting it back, I'm just going to leave it as a fraction. So what we have figured out is that the equation for this line L is going to be y equals 1/2 x plus 3/2. So we're going to use that equation momentarily. So the next thing that we need to do is find the equation for the line that's perpendicular to it. I drew that perpendicular line on our screen. So again, the first thing that we need to do is find the slope. And in this case, we know that this line needs to be perpendicular. Now, the slope from the line that we just found is 1/2. So the slope of the line that's perpendicular is its opposite reciprocal. So we're going to use -2. The next thing that we're going to do is find the y-intercept. So in this case, we're going to use that point P from the previous slide, and that point P is 1/7. So just like we did before, we're going to substitute into the slope-intercept form. So I've got 7 equals -2 times 1 plus b. 7 equals -2 plus b. I'm going to add 2, so I get 9 equals b. So our other line, our perpendicular line, we have y equals -2x plus 9. So we have the equation for the line that we drew, line L, and we now have the equation for the line. This is the one that's perpendicular between point P and the line we started with. So now I want to find that point of intersection. So from here, I'm going to solve as a system of equations. And in this case, I'm going to choose to do it by elimination. And so our two equations again are y equals 1/2 x plus 3/2 and y equals negative 2x plus 9. And now what I recognize here is the x terms. I have a positive and a negative. So what I'm going to do is multiply the first term by something so that x becomes a positive 2. In this case, I'm going to multiply by positive 4. So my first equation ends up being 4y equals 2x plus 4 times 3 is 12, divided by 2 is 6. And then I'm not doing anything to the second equation. And from here, because I have opposites, I'm going to add my two equations together. So I get 5y equals 15. And again, because those are opposites, we add them, they cancel. And then I divide by 5. So y equals 3. So this is my first coordinate of our point of intersection. Then what I'm going to do is take this 3 and substitute it into one of my equations. And I'm going to choose that second equation. So I'm going to put 3 equals negative 2x plus 9. And now I'm going to solve for x. Divide by negative 2. So I get 3 equals x. So here's my x coordinate. So what I have found out is our point of intersection for where I drew that perpendicular line down is at the coordinate 3, 3. Now, that still doesn't get us to what the question is asking us. It actually wants us to find the distance between them. So we're going to use that point of intersection, the 3, 3, and the coordinate pair for P, which is 1, 7, and then the last step is we're going to use the distance formula for them. Again, point P is at 1, 7, and then our point of intersection that we just found out is 3, 3. So we're going to use these coordinates to help us find the distance between them. So again, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And all I'm going to do from here is substitute our information in and then find the answer to this. So distance equals, and I've got 3 minus 1 squared plus the quantity of 3 minus 7 squared. 3 minus 1 is 2. 3 minus 7 is negative 4. 2 squared is 4. Negative 4 squared is 16. So I get the square root of 20, which is approximately 4.47. And so what we have figured out is the distance between that point P and our line is 4.7 units away from each other. Now let's take a look at what happens if we have two parallel lines. And so we have these equations, y equals negative 3x minus 5 and y equals negative 3x plus 6. Here's our first equation, and there's our second equation. And now what I've done, in order for me to create this perpendicular, is I found a point on the line right here that's sitting right on the coordinate, and then I found another one. To make a perpendicular line, I kind of use the idea of slope. Down 3, right 1. So I go over 3, over 1, 2, 3, up 1. And so by doing that, what I've done is found 2 points where I can make this perpendicular. So from here, we're going to end up finding the distance between these two parallel lines, very similar to what we just did in our first example. So the first thing that we need to do, forgot I want to call that equation P, or line P. The first thing that we want to do is find the equation for this line P. So in this case, I'm going to use the point slope form to start this. And again, point slope form is y minus y1 equals the slope times the quantity of x minus x1. And again, I'm going to use this point P. Again, this should be negative 1, negative 2. Sorry about that. This point P right here, I'm going to use negative 1, negative 2. And my slope to go from here to where this right angle is up 1, right 3. So that's where I got my slope of 1/3. So I'm going to substitute what I know. So y minus negative 2 is plus 2 equals 1/3 times the quantity of x plus 1. I'm going to distribute my 1/3. And then I'm going to solve for y. So in this case, I'm going to subtract 2. So I get y equals 1/3 x. And it's negative 1 2/3, so I'm going to leave it as negative 5/3 because we're going to, again, like before, we're going to use the systems of equations to do it. Now, in this case, because I use this point -1, -2 from this first line, we're going to end up using this second equation for our point of intersection. Okay, so our two equations that we're going to use are the ones that we just created. So we've got y equals 1/3 x minus 5/3. And the other equation that we haven't used yet. And in this case, I'm going to solve by substitution. So I'm just going to set our two equations equal to each other. Okay, and I like to get rid of these fractions. So I'm going to end up multiplying everything by 3, which gives me x minus 5 equals 9x, negative 9x, excuse me, plus 18. And now I'm going to solve for x. So I'm going to add 9x to get 10x minus 5 equals 8. Oh, I forgot that darn x. Okay, 10x minus 5, and now I'm going to add 5 to both sides. So I get 10x equals 23, and divide by 10 to get x equals 23/10. Now from here, this isn't our complete point of intersection. We do need to find our y value. So we're going to take this 23/10 and put it into one of our equations. And I'm just going to use the second one. So I got y equals -3 times 23/10 plus 6. This gives me -69/10 plus 6. That's -6 9/10 plus 6. Oops, that should be not 9. That should be 10. Which gives us -9/10. So in this case, our point of intersection is 23/10 and -9/10. And just like we did with the first example, we're going to use this point of intersection and our coordinate pair, this -1, -2 that we used from that first line. So again, we're going to use the distance formula. So distance equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and we're going to substitute in our information. So 23/10 plus 1 quantity squared times the quantity of 9/10 plus 2 quantity squared. So I'm going to use common denominators. So I've got 23/10 plus 10/10. And then I've got -9/10 plus 20/10 quantity squared. So 33/10 squared plus 11/10 quantity squared, which gives me 1089 over 100 plus 121 over 100, which gives me 1210 over 100, which when you simplify that becomes the square root of 12.1, which is approximately 3.48. So that's the distance between those two lines.